I want to show you some timber framing detailing, because when we're doing a brick veneer or a timber frame and clad, it's all starting with the basic same premise. And I'm going to do this in a two-dimensional way because we're just talking about timber structural understanding or timber detailing understanding. We're not getting into the 3D or the BIM components of how we actually create this with something like AutoCAD or Revit. So in terms of the 2D detailing, I tend to not use 1 to 20 in terms of full wall sections because you're repeating a lot of information that's really unnecessary. Instead, I want to focus on the critical junctions or the typical junctions. So in this case, we have a typical junction through a ridge. We have a typical junction through an eave. Typical junction of a brick pier into a ground. A typical junction of in this case, it's a brick veneer wall, brick pier, timber frame floor, and then obviously a timber frame wall inside of the external brick cladding. This is a slightly different detail where we're going from brick veneer to timber frame and clad. This is a timber frame and clad wall, so this is the top of this detail, and in this case we're through the eave of the roof or through the barge of the roof because it's a gabled roof structure. And on the other page, we've got the other missing ones. In this case, it's got a bullnose roof, and so we've got the outside of the bullnose roof. We've got the eave where it matches to the bullnose. We have a floor, an internal floor junction in this case, because we're going from a bedroom floor to a bathroom floor, and so we're stepping the structural floor structure. Similar to the other one, but this time this is the bathroom floor in its relationship to outside. And then a typical window detail. So again, a brick veneer structure where we're going from timber frame to brick, and how does the window relate to those? And so we're just looking at small segments of sections. Now, if I open these up, let's go back to the first one. This is on a layout, so we're going to explain what this is in terms of the model view. But if we look at this one here, this is the one we're going to start with. And the way that I typically do these is that I'm using if I go back here and explain this from first principles, I'm creating an independent detail. So all of these are just drawn with fills and with lines and dimensions and annotations. This is based off a detail marker. So when we're producing details in AutoCAD, it produces a two-dimensional version of something. But what I'm really doing is I'm creating a trace reference. So if I trace, I'm actually tracing part of the real building. And when I'm doing this in AutoCAD, it's really important that I'm tracing in line with the horizontal situation of the reality. And of course, another way of doing that would be I could delete these details because these details are actually meaningless, and I could move this into place. So I'll just move this across, and the idea is that this should have a complete relationship with what's happening here. So I'll turn the trace reference off. So what we're seeing is the trace reference of the 3D model behind, because the way that I will typically work is that I'll model this. So I'll model it using 3D elements, and then I'll create much more detailed two-dimensional versions of what I'm doing. And then I may even turn that into a 3D complex or a complex profile, or we just now call it a profile, which I can then make the model more developed based on this two-dimensional detail. So now that we're looking at this, what are the elements and how do we need to understand this? So in terms of a timber frame building, we've got a timber frame wall, we've got a brick veneer building. So in this case, the timber frame wall is the structure. And this is more of a traditional based roof. So we have a larger rafter, which is exposed in some situations for the rest of the building. So I again turn that trace reference back on, and we see that the rafter is exposed through here. And then we have a ceiling over the bathroom element. So at the moment, we're looking at the ceiling over the bathroom element. So we have a ceiling frame and then a rafter. This particular project is based on a flame zone BAL requirement. So bushfire assessment level flame zone, which is the highest, which means we need to go to a higher level of detail in order to be able to make sure it's protected from bushfire. And one of the ways that we do this, we need to have things like shutters on the outside of windows. We need to add rock wool insulation. And in this case, we need to have plywood on top of the rafter. And then instead of having just a small timber batten, I've got a larger steel section. So this would be a purlin. Then I've got the ceiling insulation on top of that. And then I've got the roof blanket on top of that. So it's a little bit of a build up. It's not necessarily a traditional structure, but I just wanted to show you a proper professional detail first. Because of course, if it's really generic and standard, the reality is we don't need to draw it for the builder. So when I'm teaching you and it's about learning something from scratch, of course we draw it from scratch. But when we're drawing something as a professional, we really only need to draw it if we need to draw it. We only need to draw it if we need to communicate it to someone. In this case, it needs to be drawn because it needs to be approved because it's a bushfire situation, and because it's a little bit more technical, the builder wanted to ensure that we had a really clear understanding of what we were trying to create. So let's now create this from scratch. So we're going to go to New Independent Detail, and we're just going to call this Timber Framed. When I draw in AutoCAD, I tend to draw with fills straight away. There's just no point in drawing lines and then adding fills to it, which is unfortunately how we have to work in AutoCAD. I'm going to use a drafting fill because it just gives me access to my whole range of fills, and I will use a 25% fill. I'm using a projector at the moment, which is meaning I've got a very, very small screen, and so I can't see everything that I need to here. So if I go into the settings, I'm going to change the color. So I want the foreground color just to be a timber color, so a brown in this case, just so I can see it. And at the moment, I'm going to make it a little bit thicker because I'm representing the section of the timber. So when I'm drawing a timber, we're going to use a 90 by 45 frame pretty much throughout. There's a couple different ways I can draw. I'm going to use the rotated rectangle. So I'm going to move in one direction, type in 90, move in the other direction. I was holding shift before as well, by the way. Type in 45. Now, unfortunately, I've got a setting here which I'm going to turn off. I'm going to click, and that's going to tell me the size, the area of this fill. I'll turn that off. I don't want to see the area size text. My screen is too small to be able to see anything at the moment, unfortunately. I'm going to have to change the size of this. Just going to turn off my control box so I can see the scale. And so at the moment I'm working at a scale of 1 to 10. So I'll typically be working at a scale of 1 to 5 or 1 to 10. And that means when I turn the true line weight on, we can see that the edge has a bigger thickness. In this case, that's because I'm using an outline of 5 millimeters. So if this is supposed to represent a piece of timber, a structural piece of timber, rather than dressed timber, I'm going to add a cross through that. In this case, I'm going to add a cross through it using lines. Now this is the standard piece of timber that I'm going to use, so rather than redrawing it every time, I'm going to group that together, so Control G, and that means I can just copy this piece of timber again and again. Now this is going to be my bottom plate. That means that I then have a stud which extends up beyond that, so let's just draw something to represent that. In this case, I'm going to make this lighter. And this stud might be about, in a standard situation, 2400 or thereabouts. Let's copy this bottom and we'll move it up the top, and then I'm going to explain what I'm talking about a little bit more. Now, if this was our floor and this was our ceiling, we need to have as a minimum 2400. If I measure that, of course, that's 2490 at the moment. Now, because that's our our finished minimum, 2400 is our finished minimum, we need to allow for, say, flooring on top of that. So if I was to have some type of flooring on top of the structural flooring, let's say that's 20 millimeters, and then let's say I was going to have a batten that came down below the ceiling joist, let's say that was 35 millimeters and then 10 millimeters of, say, plasterboard underneath that, I might end up with a finished floor level of 2425. Now that's okay. I don't want to be exactly 2400 because if I'm even a millimeter less than 2400, I'm not compliant. I'm breaking the law. So it's really important that I keep that to be as high as possible. Of course, I'd prefer to have taller ceilings. I'd prefer to have 2700 high ceilings or 3 meter high ceilings. But at a bare minimum, in terms of complying with the BCA NCC, I need to be 2400. So that's the first bit. We've drawn a bottom plate, we've drawn a top plate, and we'll have a look at some more detailing, and I'll do this as a series of videos just so you can follow along. Otherwise, I'm going to talk hours and it might be a little bit hard, and that way I can stop and you can ask questions.